Good morning. Welcome to the lecture series of Introduction to Smart Manufacturing. Previous classes we discussed basics of smart manufacturing and what is the need of smart manufacturing. In this lecture, we are going to discuss about the evaluation of smart manufacturing. And before I also discuss what exactly manufacturing and how it is started manufacturing. So the evolution we'll discuss. So later we stages we move to the smart manufacturing. So overview the from the previous series of lecture. So smart manufacturing uses AI, IoT, and automation, which creates efficient and the connected, flexible production system. Also, we discussed major drawbacks or during adopting traditional manufacturing methods. And when we only rely on a manual manufacturing process, what is the performance of a manufacturing sector, how it is decayed. So during that, we discussed the various different between uh, methods adopting with smart manufacturing technology with conventional manufacturing. After that, we also discuss how it is benefit to especially supply chain sectors, and also we discussed what the benefits when we adopt with those kind of technologies. We also discussed how we can able to build this infrastructure for automated manufacturing systems. So we know in the from last 18th century, so industry revolution started with mechanization. That's generally we called as industry 1.0. So more majorly the people have started to think about moving materials or take like journey issues like moving them one place to another place took lot of time. To avoid that, they started to think about adapting of various medias, maybe uh, through animals they started to travel. Then it is limited to up to certain set of crowd, like maximum 2 to 4 or maximum 10. So when we want to move the large scale people from one place to another place, so they started to think about any engine can drive these people from one place to another place. So that's how this steam engine started to evolve in 18th century. So we witnessed, especially our generation of people, we can see those steam engine power railways, how it is moved through our videos, how it is shifted the handcrafting and mechanized factories, because most of the materials are not available in one place. To manufacture, we required similar kind of materials, and which required a lot of raw materials, and those raw of materials we need to transport from one place to another place. Not only the people, so it is also now it is required for various industries. So it is not limited to only the people and raw material or supply chain. So they started to use this for steam engine, for hydro like power plants, and so many, and especially uh, to light up the material in dark environment. They started to use this kind of technologies olden days. Later, you can see this Industry 1.0 engines. In 2.0, some of the factories have started to explore in 18th, 19th centuries. These products are limited into the particular peoples. So then they started to use this material and to make the availability of the material to the most mass production systems. So that's how the only the steam engine kind of technology will not serve the purpose of this most of the production mass production products. They started to change this technology, power generation technology from steam engines to the electricity. So that's how the electricity enabled factories have emerged in most of the countries. And when we want to manufacture any product, it should be set up is required with the proper directions. Otherwise, the production delay will happen. It directly leads to the product lead time. So that's how Henry Ford started assembly lines for various manufacturing factories. In fact, in his name, there are automobile companies emerged. So rise of mass production and interchangeability parts is plays a major role to improve this mass production capabilities. There, we can see the in 1930. So there is a seed company from Ford model. It's a T. We started production T line production. So where we can see the entering the raw material from one side and up to the assembly and dispatch section will be designed based upon the production line shape as T. So this took generally 12 to 13 or 15 hours sometimes, even though it is automated. Now it is reduced to the 1.5 to 1 hour assembly of any product, any car assembly. So this impact mass production at lower cost, but rigid system will get high inventory. So in Industry 2.0, where we witnessed in the common lathe machines, so such as uh, required to uh, uh, product manufacturing or to machine any lathe, any shop. So these kind of machines have required essentially. So this is semi-automated. So where you can reduce dia of the shaft or do you can do the knurling and based upon the product design, we started to do the manufacturing. So after Industry through 3.0, the automation plays a major role in especially 1970s to 2000, where contribution from electrical electronics and computer science have integrated those technologies with the mechanical and many other various subjects and disciplinaries. So this made it possible to make the most of the factories so IT enabled automation factories. So with this, so PLC, that is programmable logic control units, have plays a major role to make the CNC machine with the robustically and with the integration of computers. So in 1980s, Siemens-based PLC integrated unit have started for automated production lines for in automotive and electronics. So this improved a lot in precision and repeatability, but it is also have a limitation that integration of its ecosystems across various factories. So that's how. So if you any factories wants to connect with the uh, interdepartmental or other factories to be incorporated the data with the existing or the similar kind of factories, it is very difficult for the companies to, especially to verify the inventory level at various factories of same brand or same company name. So it is not possible. So this leads to the management to verify, monitor where the material is, which factory's material is making a shortage, and so that they can't able to uh, control the inventory systems. So to avoid this kind of things, so this is one of the invention in later 1970s and 2000 is emerged, where you can give the command through PLC. So the G code, M code generally we use to do the part manufacturing or part machining in the factories. So in the previous image to industry 2.0, where you need to give feed or do the operation manually to achieve the particular shaft or any shaft dimensions based upon the drawing requirement. However, here after incorporating your computers and PLC into the this automated uh, lathe machines, where you design and you can give the feeding or through manually on the dashboard. So based upon that, it will started to uh, do the machining based upon the requirement. So when it comes to industry 4.0, the limitation we have seen in industry 3.0 where we can design and but those design changes cannot possible while doing the manufacturing of the particular part. So when it comes to industry 4.0, if the operator is not near to the factory or near to the machine, if he identified the parameter needs to be changed. So based upon that, the design needs to be changed. However, is not near to the factory. So in industry 1.2 3.0, so that problem existed till 2010. Later stages in industry 4.0 technologies, apart from including PLCs and computers, the new thing is added, that is cyber physical production systems and Internet of Things and cloud computing and AI enabled integrated units to the factories. So the advantage, especially in cyber physical systems, as I told, if the company having a brand name of X, the company having the sub factories in various cities like X1, X2, X3 up to X10. So when the material is importing from any other countries to the existing countries, once we receive the material, so based upon the demand, the material is going to use. Some places, after using of this product to manufacturing any product, the raw materials try to reduce. Apart from that, when the industry is running, in case a factory manager or operator is not reachable to the factory or to the machine, he can also control the entire machine by staying in or by changing. So when it comes to digital twins, so it is a replica of the machine where we can understand the uh, machine condition during it is working, and if any abnormality condition we can observe, so that immediately we can take action, which also it is possible with the predictive analysis, such as parts like bearing. We can expect the machine bearing failure, so that help the operator to uh, start to its own preparation to purchase a similar kind of bearings to avoid breakdown of the machines. Full system integration and decentralization is possible with IoT devices. Most of the times, if the operator is not able to give the command for similar kind of operations which is doing regularly, so in that case, the edge devices or IoT edge devices, which can take decision it automatically by understanding its previous data and give the its command by understanding its design, by understanding its process, and it will start its own decision making in that particular area. A company called Bosch in Germany is started to adopt this technologies very quickly, and they have adopted the various sensors which is required for the machinery and IoT devices and AI enabled softwares and devices which minimize especially defect rate of the product, because in during running time of the machining of product manufacturing, it itself it will verify its own defectiveness and take the decision making, and it minimize those issues during manufacturing. It impacts high responsive and efficient and customizable production environments. Where you can see this a modified version of the lathe machines of conventional lathe. This is Industry 2.0 lathe, which also can be possible to modify to Industry 4.0. This is rigorously this developing with some of the labs in India, especially in IIT Delhi, where they are adopting this Industry 4.0 technologies and integrating those in sensors and PLC systems to the conventional lathe, where they can able to develop advanced Industry 4.0 lathe machines. Especially these PLCs will get the information of your input data and output data and analyze and control entire lathe machine operations, and IoT gateways will receive the commands which is coming from the operator or the machine operating positions. All the data will receive through the PLC through to the IoT gateways. It is a media between the operator, a connectivity system between an operator and to the lathe machines. But sensors like vibration, temperature, and RPM, these are the general parameters when we want to control a lathe machine, like a speed, like a feed, and dough cut, and vibration, where we can see in terms of the simple symbols, and where we can also predict if the operator, if the uh, increasing RPM, how it affects. So immediately we can see by uh, observing the symbols of the different three colors. So towards Industry 5.0, that is human centric and sustainable manufacturing, most of the industries, it started to material. When the material comes to the factory, the human intervention starts from unloading, loading, and placing the materials to the warehouse. Assume that a lot of materials received through any vehicle to the factory. If a human is not there, then adaptability of robots is essential in that environment. But however, in a vehicle there are various kind of materials, maybe components like simple shafts, components like critical part like electrical parts, hardwares. Another boxes will be like sensors based, highly costly materials. After receiving the material, a robot itself cannot able to judge what kind of precision we handle to the from the warehouse, from the unloading station to the warehouse. So since the limitation having the robots, the collaborative robots have emerged. That's cobots. Cobots will identify the materials and criticality, and it feed already the data which is to be take care very carefully, and it analyze from its own through internet how to handle this material, and based upon that material precision, it will move this cobots to the particular warehouse and it will place to the particular bins after RFID or any other scanning device coding completion. So it emphasizes the personalization and sustainability resilience by adopting these technologies. The use of this ethical AI and green manufacturing technologies, which leads to uh, improve the uh, environment responsibility as well. Most of the robots or cobots are nowadays it's adopting like small scale industries to gain this advantage. Summary of this: Industry 1.0 introduces mechanization through steam power. Tensile mills mark the shift from manual labor to the machines. In Industry 2.0, which enables the mass production via electricity and assembly lines, and Ford Model T line revolutions happened in Industry 2.0 era. When it comes to 3.0, it emerged automation possible with the help of the electronics and PLC, computer numerical control machines for mechanical engineering, and robots for assisting the automation systems. And Industry 4.0 before generally focuses on digitalization with IoT and AI enabled digital twins. When it comes to 5.0, it promotes human machine collaborations, sustainability, and customization using cobots from various universal robots. So, the continuation of this topic, we also can observe impact of Industry 4.0 and benefits in smart manufacturing. So this is just a recap, which already discussed. So the impact is like significantly boost the automation in operations, reducing human error, enabled real-time production control systems. So with this, most of the companies started to gain the advantages. Like major companies like in German-based companies and Siemens, they achieved production quality up to 99.99 percentage and automation of production process 75 percentage. And by using this IoT and AI enabled sensors, they can able to develop a quality product during inspections. And by adopting digital twins, this company started a remarkable outcome from the product quality checking. Some of the companies, they have started to adopt this technology for predictive maintenance and reduce downtime. So the impact they have created, companies like GE, AI enabled sensors and smart sensor they adopted in the health monitoring of the machines. So they generally plan this to unplanned downtimes. With this, they've a- achieved the downtime of minimizing downtime of the machine by 20 percentage. And by adopting digital twin and simulate machines behavior, fault detection of the parts can be identified with very effectively. So to achieve the quality of a product checking and controlling, some of the companies already adopting this, such as like Honeywell for real-time detection of by using image processing technology like machine vision, incorporating with AI, which improves the first pass yield and reduce work of the manpowers. So this AI inspection reduced defects by 50 percentage, and the real-time visual analytics have far more important in during production line. Some other companies like motors and generator manufacturing companies like ABB, so to improve the energy efficiency and sustainability, they have started to adopt these technologies, especially to reduce energy consumption and waste in the real-time motors and manufacturing. So during this, so ABB adopted the smart sensor and motors, which can able to reduce the motor's energy by using IoT devices to predict the machine failure by using condition monitoring techniques. It is also used to minimize the downtime and carbon footprints in the industries. Generally, it generate during manufacturing process. Summary of the complete this importance of smart manufacturing. So, which boost productivity through automation and real-time control. This is proved by Siemens, which reduce downtime via predictive maintenance with AI. Some other companies, and which also improves the quality using AI-based detection systems, proved by Honeywell, and enables customization with agile manufacturing on-demand production here. And later stages, this company like ABB, which enhances sustainability, and cutting edge technology like IoT and predictive maintenance. They've successfully implemented to minimize wastage footprints, minimize footprints, and improve the energy efficiency utilization properly to achieve the uh, proper goals of Industry 4.0 technologies. So, with this, I can say this technologies help for many industries in terms of improve the quality, in terms of increase the productivity, and minimize wastages and reduce fatigue to the employees. Thank you.